Sorry, what? 2A? All right, well, why don't you tell me what it is? Why don't you just say bracket, open, close, or something? For all x not j of x. All right. We might not got all the brackets right. In fact, where these came from is somewhere I got a PDF and ChatGPT did its best to convert it into LaTeX, and then I did global change and replace, and I know the one place that it kept screwing up was brackets. So the brackets could be all wrong. But anyway, let's step back and see this, right? We have for every x, we have j, and we have that there exists a y. If all that's true, then there exists a y. For x, it does not exist a j. Now, this seems funny because it says for all x, j is not true, implies that there exists an x where j is true. Is that right?
Professor, please share the
Um,
screen.
that seems awfully weird to me. Uh, just the y. Hmm? Right, oh, right. So why don't we bring it? See if we can bring it up. Um, Oracle game. Yeah, maybe this is, yeah, it's better to have them up here anyway. What question is it? 2A. Um, 2A, sorry.
Good morning, Professor. We cannot see the screen. Would you please share the screen to the Zoom?
Yeah, well, that's certainly what it says, isn't it? Oh, oh, here we got the Yeah, so the brackets are wrong. So it says, let's see if I have it right. In fact, was it right here? Yeah, yeah. So I made the brackets. I got the brackets wrong. All right. So where is it? All right. So I mean, maybe that people can read this just as what even better, right? So the key that things I was changing is HBY means H of B in Y, right? And they use this symbol for the implies, and this line means if this is true and this is true, then this is true. Right? Can people read this? Yeah. Yeah. So this is notation for when you're setting up rules for a proof system, right? It says if you've proven this and you've proven this, then you can have this be the next line of your proof, right? So it's sort of an improves. And so let's try to figure it out. It says if J is false for all X, all right, so let's let's play the game. All right, so what we want to prove is the statement down here, right? We're wanting to say that something is true for every Y. So how do we start proving something is true for every Y? Yeah, let Y be arbitrary, right? And then we could, if we want to worm ourselves, sorry, first off, assume Oracle 1 has the first statement and Oracle 2 assures kind of the first statement and assures the second statement, right? Where these statements are this one and this one, right? And then if we want, we can say our goal is to prove, right, the third statement. And this third statement, so then we let X be arbitrary, right? And our goal is to prove P of X, Y, and not Q of X, Y. Right? Is that, oh, no, I jumped lines. Oh, it's, in fact, I got that all wrong. Completely wrong line. Everybody watch me when I'm making sure I'm not. So what are we trying to prove? We're trying to prove it's not the case that H of B, BY, or RYY. So did I get that right? Yeah, RYY. So everybody follow this so far? Yeah. There exists a Y. Yeah. So our first, yeah, we're doing this A here. So the first oracle is assuring the first line. The second, or this, yeah, each line above the line is an oracle. And the thing after the oracle is what we need to prove. Yeah, yeah, yeah. So this notation means if this is true and this is true, right? So the way I was trying to do it is this, and then this thing implies this thing is would have been right. Right? Everybody kind of buy that? And so why do we write all this down? Is well, we definitely have to proof by deduction. We have to make our assumptions, and then it's just here. It's it's good to, for both your sake and the marker's sake, it's good to state what our goals are as a reminder, right? So here, this line here says, well, we're trying to prove 3. And then it starts with a for all. So we say we have an arbitrary. And then why do we put this line here? If nothing else, to right, to help you and everybody know what our goal is, right? And then it's not the case, H and R. So it's kind of, we can see here that this not H and R is kind of, it's up here already, right? So that's we're good. Yeah. 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 So well, what would you put between the first line and the second line? I mean, there's kind of an and. You have two sentences. Right. Well, you could have only one oracle that assumes the and, right? And then the first thing you would have to do, one of the things you'd have to do is do separating and to make it into 2 lines, right? And then you could say, well, the first oracle is assuming the first line, and the first oracle is assuming the second line. And why did I make it 2 oracles? Only to make the notation better. When I talk about oracle 2, you know we're doing the second line, right? I mean, and we kind of did it twice. We can talk about the second line. I've named the second line kind of. And this also, if I say oracle 2 does something, you'll know that we're talking about the second line, right? That's just what I did to, right? I have some slide somewhere that says it doesn't matter if you have 1 oracle or 2 oracles, right? They're both helping you. And then they're buddies, right? So they can help each other too, right? Does that make sense? Everybody good when we start it up? All right. Now, what we're trying to do is the negation of, right? If you look at the second oracle, right? It's an implies, and so how are we going to get the thing we want? No, deduction to me means how do you prove an implies, and this is the opposite. We have the implies, and we want to use it, right? Exactly. So I'm just, I would start by, well, one, how could you approach this? The one approach is I have this Y, and what could I do with it? I want to give it to an oracle. And there's only one oracle that's receiving things, right? So I could start by just giving it to her. But I can also start thinking big picture. Text, just this text and this text look the same, right? The only difference is this one is a not. Well, that's kind of nice because if we do modus ponens, or we do contrapositive, we have to prove this will prove not this, which is what we want, right? So we're definitely going to be, our goal then is to prove not, I guess our goal is to prove not this so that we can get not this. And then again, how are we going to get not this? Well, up here is giving us a not this, which agrees with the fact that we have a y and we need to give it to somebody, right? So we can say, hey, let's give our, here, let's make it put the for all there, because that's right. The x is sort of a variable, and this is a specific value, right? So let's give this value to Oracle 1, right? And then what does she say? Oracle 1 says for all x, I keep changing lines here. This is an arbitrary y. Everybody, you got to be correcting my mistakes better. All right, let's make this big so we don't see the wrong line. Maybe that's too big. Okay, let's make it small again. Sure does bounce around. All right, that was a fail. That was a fail. We're gonna we got for all y. For all y. Okay, did we fix it? Right? We gave it to Oracle 1. And what does she say? She says something is true for all x. So true for your y for all, i.e., I assure you that, okay, what is she assuring us? She's assuring us it's not the case that J of y for all, right? Is that what she's assuring us? We plug in what she's assuring us. All right. Then we're done with Oracle 1. What does Oracle 2 do? Exactly, right? So Oracle 2 gives us y exists, and she assures us that, okay, let me copy this down right, H, B, Y, or R, Y, Y, big brackets on this, gives me, there exists an x such that J of x, right? Yeah. Yeah, so this is the tricky thing, is she will only give you this if you promise her this, right? And so unless we can promise, we don't have anything. Well, just first off, what are we going to do with this? We can either prove this and get this, or what would be more useful? Prove the negation of this, so we get the negation of this, right? So let's do let's do the contrapositive here, right? So we have, it's not the case that there exists an X that that's J of X gives me H of B, Y, or R, Y, Y, right? Negation. All right, so here we got, if this is not true, then all right, so actually, let's pause for a minute here. I think and see whether we've done this wrong already. All right? So this is where the parsing comes in. So does this Y just apply to this? Or does it apply to this whole thing? And I looked up on Google, and the exist just grabs onto this bit, right? Not to mention there's no Y over here anyway, right? So I'm going to say that I'm doing this wrong too, right? So she doesn't, let's start all over, right? She doesn't give us an X, right? The bracket, I think that she doesn't give us this because it's only on this side. It's not on the outside. All right, people with me here? So, she doesn't give it until somebody can prove this thing, and there's an implies here. All right, so let's start with Oracle 2 again. Oracle 2 is assuring us that if it's not the case that there exists this, then it's not the case that there exists this thing. That's better. People with me now? Am I losing anybody? Yeah, I'm losing you? All right, so let's focus again on the second oracle, right? First off, we do need to be able to build the parse tree, right? And so to build the parse tree, you have to say kind of what's the last operation or what's the first operation, right? First, how does the bonding here work? Right? First, these things, this or is in a nice bracket. So that's together, right? And then this binds to this first. It has a stronger binding than the implies, right? And in fact, I think when I was typing what we have, I think I probably saw we needed extra brackets because of that, and then I brought it too early, right? So this is kind of one object, well, not one statement, and this is one statement, and it says if this statement is true, then this statement is true. Yeah. She doesn't give us a Y yet because what she's giving us is that she's giving us a big A implies B is what she's giving us, right? So Oracle 2 assures A implies B. Now, the fact that there happens to be an X, an exists here and an exists here is not our business right now, right? She's not assuring us. If she assured us of A, she would give us an exist. If she assured us of the B, there would be an exists, right? But at the moment, she's not assuring us of either. She's assuring us that if A is true, then B is true. Right? Yeah. Yeah, so she's assuring us that A implies B. So she's also assuring us not B gives me not A. Right? Yeah? Yeah, if we prove A, she'll give us B. If we prove not A, she gives me not B. Right? What did I say? She gives me A, she gives me B. I prove not B, she gives me not A. Yeah? Yeah, right, exactly. So what I did wrong is I just looked at the beginning of this and saw, oh, this is exists Y brackets, right? And I just assumed that the exists Y was applied to the entire thing, right? So if this bracket matched up with something over here, then she would be giving us a Y, right? But this bracket doesn't. It clearly matches with this Y, with this. So she's not giving it to us. Yeah. Yeah. Yeah, it probably, actually, I think it wouldn't change the problem that much. I don't know. Actually, I don't quote me here, but you would still, there would still be an A implies a B, and you would have to prove one to get the other. Right? So we have this big thing here, and we don't quite know what to do with it. But if we could prove this, right? In fact, this is what we want, right? In fact, let's look at even the objects are right, a by and a yy, right? This is exactly what we want to prove, right? So we can then say, right? Our goal is to prove that it's not the case that there exists a y for which the j is true, right? This is like, I'm saying that's what we want to do, right? Because then we will get this, right? Right, everybody kind of following that? All right, so now I want to say, how do I prove this? Well, let's go back to our oracle. Our oracle says that J for this Y is not true, right? Right, so we come back to our oracle 1. Right, so let's get rid of this. And so we have this statement here, right? What can we, and what we want to get is this statement, right? And do they go together? Right? They absolutely together. This, right? There's a formal rule where you can add the exists, right? Here we're saying, look at this is true for this y, and hence we have this. Right? People buy that? And if we have this, right? Hence we have this, and hence we're done. Right? Everybody in a good solid panic now? Yes and no. On one side, right, once we got sort of breathed a little and we put in the brackets, right, the game fell out pretty naturally. No? No natural. Yeah. Yeah, I mean, I didn't know, how much parse tree, sometimes I'm giving you lots of parse tree and sometimes I'm letting it go, right? So let's build a big parse tree and see if it helps, right? So this is blue and I need to prove it, right? So what do I want to prove? Well, first, we can kind of come over here and say the adversary gives me an arbitrary universe, right? In fact, I forgot to put that here, right? Where does this H, should these objects come from at all, right? We should have started with some adversary gives me an arbitrary universe, right? Because we're trying to prove that sentence is valid. We're trying to prove it's true in under every universe, right? So just as a reminder of that, we could start by saying the adversary gives me an arbitrary one, right? And the truth is, let me tell everybody, I put that into my solution set, right, this first line. And so, right, the TA might be looking for it. Right? Everybody good with that? Right? And then what is our goal? Is to prove that whole thing, right? And then we go over here, Oracle 1 assures 1, and Oracle 2 assures 2. And our goal is then to prove the bottom line, right? This is kind of our 3. And then we parse this, and it says for all y, not this bracket thing, right? So everybody get this part of the tree? So let's think about this line here. It gets parsed into a big A implies B, right? And when I was trying to come up with a game for telling you how to always do this, I must admit I kept getting I was kind of stuck on how to do this, right? What colors to make this. And so what I was kind of saying is well, let's make this blue and this yellow, meaning if she's just assuring us that if A is true, then B is true, right? But how do we get this? Well, somebody else has to prove it, right? So if the prover proved this, then she will assure this, right? But that's not in fact what we did, right? So this is an example where what I put in my slides isn't actually good enough, right? Because what we did instead is we changed this to a not B implies not A, right? Oh, and then I should have erased this because then we make this blue prover and we make this yellow assures, right? So how did we do it? It was, well, and then we proved this somehow, right? And how did we get this? Well, more or less Oracle 1. Let's have this be a dotted line because it's not part of, it's our crosstalk, right? This guy here assures us of this, right? And you might say, well, then that's not blue prover. Well, in some ways, she's assuring it to the prover. Now the prover has it, and the prover is assuring it to the oracle, right? And now when the oracle knows this, so the oracle assures of this, right? Which then very nicely gave us this, right? And I must admit, it's all pretty scary, right? But not so bad, right? Come on. She's like gone. Yeah? Yeah. Well, I'm sorry, I didn't quite get how are you parsing it? What's this mean? Oh, the line. I don't know what this is. We have a for all x, and then we have an A implies B, and then we have a line, and then we have for all y. Right. Well, then what are we proving? Yeah. Yeah. So I mean, I never taught you that there are a number of things about this notation that I didn't teach you. And that's why I translate it. I was trying to translate it, right? So this definitely means if you have proven this and you have proven this, i.e. you have one or two oracles to assure it to you, then this is true, right? So that's what we have to, if we want to prove that this whole thing is true, is valid. If it's valid, then in an arbitrary universe, if we're assured these things, then we have to prove this thing. All right, so that's definitely the beginning of the parsing, right? And that's one reason why it's nice to have written down at the very beginning to make sure we're all on the same page, right? Oracle 1 assures us of this. Let's say we have two oracles because they seem to be two different statements, right? Oracle 1 assures of this, Oracle assures us of this. and we need to prove this, right? And then we have to figure out, well, what does this oracle do for us, right? Well, she really only, right? She only is doing this implies for us. And so how do we get an oracle to help us with an implies? And that's another hard thing, right? No, they've never been written like that. And my goal, and I did not give this to you, really. I translated it incorrectly, right? I was trying to translate it into this and this with big brackets and an and here gives you this, right? But I put the brackets in the wrong place. Well, one thing I did have a page somewhere. How do you get to oracles? You could have A and B gives me C, right? So this is an oracle. This is, well, I don't care. You call them the same oracle. You give them different names, right? It doesn't matter. You have oracle-ish. The clan of oracles is assuring you of this, right? And then you have to prove this, right? And then I had another version which says A implies B implies C, right? Now here I have an oracle assure me of this, and then I have to prove this, right? And how do I prove this? I have an oracle assure me of this, and I prove this, right? So again, we have two oracles, right? And these two lines, we could do purple table and prove that they're equivalent, right? And the reason they're equivalent is because in both of them, you have an oracle for A and B, and I have to prove C, right? So the game is the same. And if you did truth table on the two, they would be the same. Now, what's harder is if I have A implies B gives me C. Now, this one's harder because I have an oracle assuring me of the implies, right? And it's harder to get what she's doing for us, right? In some ways, what I'm concluding is, in the various examples, is that really what we have to do is sort of go back to the purple table, right? There might be flaws and exists in here, I don't know, right? But I have to take this unit and this unit and say, as a unit, if she assures me of this, I get this. If she assures me of this, not this, I get not this, right? And only dive into what is the statement of A and B after I know how I'm going to purple table it, right? And what do I mean by purple table it is I mean, if you look at the purple table under what do I do with it implies, it kind of says what you do with implies is if somebody gives you this, you get this. And if somebody gives you not this, you get not this, right? Modus ponens, that's what you do with an implies. And, right, you could also, I guess, convert it into this is false or this is true, right? But that's not really helping us, right? So that's kind of what we have to do, right? Does that make sense? And that's kind of why I paused trying to parse this further, because because there's a big ugliness here. Right? Does that make sense? Yes. That's the hard part. She's not assuring you, she's not telling you anything about A. She's not telling you anything about B. She's telling you the implies. She's telling you, if you can promise me A, I will promise you B. If you can promise me not B, I can promise you not A. Right? But if you can't give me anything, I give you nothing in return. Yeah. Well, suppose I told you that A implies B, and I told you that B was false. What does that give me? Oh, sorry, I tell you A implies B, and right. Sorry, what did you say? I tell you A implies B, and I tell you B's true. Is that what you're saying? Right. If B's true, it doesn't tell me anything about A. Right? Because it could be true or false. Doesn't help you. Yes. Right? Because this is like, if it's a hound, it's a dog. Okay, great. I tell you it's a dog. Well, is it a hound? Maybe, right? Maybe it's a little more evidence of houndness, right? But to use it. Yeah, to use it. Yeah, yeah.
So with propositional logic, this predicate logic, or
No, this isn't a purple table versus Oracle question. Let's yeah, I'm right there. And we're doing never know when to click once or click twice. Sometimes I click twice and it doesn't happen. There we go. All right. So the difference is am I using it or am I proving it? Right? So this is the same as if I'm using it, then I know it's true. So the oracle is, we could write down here, oracle's assuring it to you. And over here, prover blue needs to prove it. So this column is kind of yellow with the oracle, and this is blue with the prover, right? So and now, so here, if implies, how do I use it implies is, well, if she assures me of an implies and somewhere I get an A, then she assures me of a B. Right? But over here, if I want to prove it, then how do I prove it? How do I prove it implies is I bring in a new oracle to assure me of the A, and then I prove the B. Right? So there's a difference between what's happening here and what's happening here. But it's the same in both, whether we're doing for all games or we're doing purple table. Right? It's the difference between this column and this column. This is I'm using it, so I'm assured it. And what do I do with it? Right? Because here it's like, in fact, here's kind of, remember, just like it's the line that was over on this test paper, right? Here, it's, here I have a line with this and a this, right? And what do I have over here? I have the same line. Well, if you have this, this, and this, right? You have an oracle 1 assuring you of this, and an oracle 2 assuring you this, oracle 3 assuring you of this, then, right? If you know all of this, then you get this for free. Right? Or this one here. Right? If the oracle assures you of this, then you have to prove this, right? How are you guys doing? Should we do another one? Should we trust my brackets? Do you like, which you prefer, this notation or this notation? I don't know, choose a question. Yeah. What? C of 2? All right. Oops. C. All right. So that one right there. All right. So okay. Anybody remember what our very first line should be? If you're going to agree with my solution set? The yes. All right. Our goal is to prove that this statement is valid. All right. So our goal is to prove A and B gives me C is valid. Right? I.e. true in every universe. Right? So the first thing we do is let all consider an arbitrary universe. Right? Everybody get what we're doing there? Right? What's in our universe? What objects are there? And what is the H, right? When is H true and false? When is T true and false? Right? Everybody got that? And then we have oracle 1 assures 1, 2 assures 2, and we need to, goal is to prove 3. All right? And I want you to emphasize this word here. And the reason is because I really do find when I'm marking people's assignments that it's hard to know, are you stating what you need to prove, or are you stating that something is true, right? So by me using that word goal, I know that you're not claiming you've done it already, right? Because if you just say prove, if I get confused, then I'm like, dude, that's what we got to do. Why are you saying it's true? Right? Everybody good? All right. So I'm not even going to read A and B right now. I'm going to go down to what I need to prove, right? I need to prove. So let's first parse it, right? What's the top level of the parse tree? It's the and, right? I got here a statement, and I've got here a statement, and there's an and between them, right? So I can come over here and say, actually, my goal, I can take my goal and say, i.e., my goal is to prove 3.1 and 3.2, right? I have two goals. So we can focus on them in different ways, right? With a different light. Let's first, how do we prove this guy? Right? Goal, prove 3.1. And this means it's equivalent to, what is 3.1, right? It's a for all x, for all y. So that how do we prove it for all? Right? Let x for all and y for all be arbitrary. Right? And then our goal is to prove h of x for all, y for all, right? And then we can do the other one. Now, it says for all x. So what do I say? Should I say let x for all be arbitrary? Yeah. It's the question, is it the same x or not? Right? And the adversary is giving it to me. So really, the adversary gets to choose whether it's the same x. So it doesn't have to be the same x, right? If we're doing bindings, this for all binds with this, and this for all binds with that, but they're not necessarily the same. I mean, they're both, in some ways, they are the same because they're both everything, right? But I think it would be, it might confuse us here to think about them being the same. All right? So what should we call this one? How do we put a prime on it? So our goal is to prove it's not the case that T prime of, right? So now we have three goals, right? Two goals. We have this goal and we have this goal. Right? Everybody good? All right, so we haven't read, I haven't read the oracles yet. All right? So let's see what our oracles are doing. The first oracle, you give it an x, and it assures you a bunch of things aren't true, right? And the other one is going to give you a y. And let's just, for a minute here, make sure we've got this parsed right. Right here, the exists is on the outside because we have these two brackets, right? And then this one I'm remembering is an or, right? So she tells us there exists the y such that this is true, or we get this whole thing. And the whole thing is talking about, right, they're existing in X, right? So all right, so let's start with is we gotta give this oracle. Yeah. 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 Yeah, exactly. Exactly. They're very good. Right? So let's do that. Right? Let's change it to Oracle 2 assures us for all y and that it's not the case that t of y in the brackets are out here, and that's an or, so we change it to and. And what do we change this to? No, because the not's coming in. Oh, for all x, right? Absolutely. Sorry. For all x, h of x, y. Right? Did we do that right? All right, so that's nice. That's nice because now we have a lot of for alls, and that's good because we're trying to prove a bunch of for alls. So we have a bunch of for alls here. And all right, so let's think about how we can use this, right? She's saying for all y, this is true. So we can give her a y. So let's think about what y we want to give, right? We need to prove this, right? So that sort of says the y I should give her should be this object, right? But over here, this is right here. The y over here is on the second side, right? So it seems like we want to give her a y, right? We want this h thing, right? We want a for all y here. So if we want a for all y here, it looks like we should be giving her a for all y, right? So everybody see that? No. All right. So my goal is to prove two things, this thing and this thing, right? So how do I prove this thing is I kind of match it up with what she has. I can give her a y, which is going to put some value in here, right? And what value do I want in here? Well, I want my y for all in there. right? So that tells me I should give her my object y for all, right? Everybody get that? On the other hand, I want to prove this, which has, and that matches up with this. And so what do I want to put in here is the y prime for all, right? So it looks like I want to give her that. But what can we do? Yeah, one, we could separate these, or we could even say, well, let's give them both to her. I mean, here's one method is well, how do you think this for all distributes here, right? Sort of saying, for all y, this is true, and for all y, these two things are true. Well, that also tells you for all y, this is true, right? And it also tells you for all y, this is true, right? Yeah, yeah, right. So I'm willing to say that we could separate these, but you should be nervous doing that because we haven't taught it to you that you could separate them, and sometimes you can't do things. Yeah. Yeah, I hadn't really gone up to the first X, first for all. I'm more just banging on the second one. All right. I haven't quite the vision of how we're going to use the first oracle, but let's just thinking about the second oracle. What are we going to do with her? I mean, let's try to forget about this for a minute, and let's just try to prove this, right? She has this here, so I'm going to give her oracle 1 y for all as y, and she assures me that y for all is true, and for all x, h of x, y for all is true, right? She assures me both of them. Right? Does that make sense? Now, what do I do with this and? Right? I separate it. In fact, this is sort of not even useful to me. Right? I mean, it's true, but it's not useful to me. So I separate. So I say, right? In fact, the way I guess I'm writing it in the thing is I'll just say for all x, h of x, y for all, right? By separating and, right? So, yeah, h. Right? Everybody good? Now I know this is true, right? What do I do with this? Right? Right. So maybe we call this Oracle 3 or something, right? Give Oracle 3. What do I give her? Right? I need to prove this. So I get my, right? So this gives x for all as x, and she right? Which then gives me this piece. What I'm puzzled about is it seems like we're going to get this without doing the first line at all. What do we need the first oracle for? Well, let's go on. Let's keep going. All right. So what were we saying before? We want to prove this. Over here, we need to prove a not of this guy, right? So we can give the oracle it. People agreeing with this? Yeah. Yeah, she's assuring me there's no reason I can't give her more than one value. Yeah. I think so. I'm still worried why we're not using the first oracle. But for all x, y, and that's an or, so we turn it into an and for all. I don't know. It seems good to me, and maybe somebody can find a bug, but now we know all of this. Yeah. Oh. Oh, she's right. Something was wrong. Give her a gold star. See that we got to be really careful with the parsing, right? No, let's see. The brackets. No, the brackets. Hi guys. Let's see. Let's build the parse tree for this, right? This bracket matches with that bracket, right? So it's definitely, I think you're not right. It's definitely saying there doesn't exist something for all of this. And what you say? I mean, the brackets are there. Well, you're saying that the negation applies just to the exists y. Yeah, but yeah, I would. It's kind of what I'm saying, right? So there exists. So there doesn't exist the y such that what? There are a big bracket, right? So if there doesn't exist the y which big brackets, then that means for all y, the negation of big brackets. Well, what's the big brackets? It's an or. So we turn it into an and, the negation of each side. So we negate this side, we get that there's not, it's not true that we got the t. And on this side, the not exist turns into a for all negation negation. Yeah, so that's another thing that this notation, I've seen this notation before, that people put brackets around the exist y. And it doesn't seem to do any good to me, right? What purpose does it serve? I don't know what purpose it serves, but I have seen it before and it's there, right? Yeah. Yeah, I hear what you're saying, but I mean, we can think about Oracle 1, but I'm still saying if this says for all y, we have all of this, well, that tells me that for all y, we have this.
The right side, you put the for all y to x prime, then the left side of the x. So you can't have that for all y be two variables at the same time.
Yeah, but the bottom line, I mean, let's focus again on what this bottom line says. It says there's an and is the top, right? So we need this to be true. Not, well, but it doesn't have to be the same x. Right.
How you using one oracle, you're putting two different values in for that single oracle at the same time. If you want to prove goal 1 and goal 2, you use different variables to the y. So if you use the one oracle, you can't go to the
Well, yeah, I do think I can. I mean, let's. Where is an eraser? What did I do? I had pen erasers? Way over there. How did I get them way over here? I can't even talk to you guys. I remember talking to you. All right. Let's I think that this is too complicated for everybody. Let's pause for a minute and do a different problem and see what we like, right? So let's just prove for all y, and we might as well use the, right? Or, let's just change the letters. For all y, and b of y implies for all y all right. Right, here's a different question, which is easier, right? So let's focus on this one, right? Everybody buy this earlier thing? Here, one oracle is assuring me that two things are true, right? And I need to prove this, and I need to prove this, right? Everybody agree that this is true, right? So how are we going to do it, right? Arbitrary universe, oracle 1 assures the first statement, and then we need to prove. Now we have two goals, right? I have this goal and I have this goal, right? Goal 1 is to prove for all y, a of y, right? I'm a bum at home too. Okay. So this is, actually, I think I even had slides about this, which we didn't really get to, is saying if I have two goals, then I have to prove this one and I have to prove this one, right? And I can do them separately, right? So let's just focus on my first goal, right? My first goal, how do I prove for all y? Right? Let y for all be arbitrary, right? And now, what do I do? Give y for all to oracle 1. She assures me of a of y for all and b of y for all, right? I say, hence a of y for all by separating and right, and hence for all y, right? We let y be arbitrary. I prove this. This is like a free variable. Hence, this is true, right? I think that's just true. And then we'd prove this one the same, right? So is everybody agreeing? Did I do anything wrong that our second oracle is this? Right? Our second oracle is this. Then we have for all y, not t of y. And we have for all y, for all x, h of xy. Right? And then, well, we can, one thing that's true is that you can flip them, right? Hence we have, we can flip them, and for all y, for all x is the same as for all x, for all y. Yeah? Yeah, so no, this statement, these two statements are separate. Yeah, in fact, let's bring this one over and turn it to a for all x, for all y. I just reversed these of h of xy. And then this thing here is a standalone for all, right? So I can use that variable is not linked to any other variable, right? So I can change it to a for all x, right? For all x, not t of x. Yeah? We're just doing this, right? Right? Yeah, but something is true for all y. So suppose she's assuring me it's. I mean, let's do it proof by picture. Here's we got our objects, and here we have A and B, right? So what she's saying for every y, for 1, we got a check. And for 2, we have a check. And yeah, she's doing it together. You give me a 3, she says check. She says 4, so we get check, right? Now what I care about is I want A of 2 to be true, and I want B of 4 to be true. Yeah, but they're true, right? The A of 2 is true because I don't know. Can you see beyond down here? Probably, okay, right. Yeah, well, right. The A2 is true if I want A2 to be true, I say, hey, tell me about 2. And she says, yeah, A2 and B2. Now I care about B4. So I say, hey, what about 4? She says A4 and B4, right? And I ignore half of it. Yeah, but where's time? Can you see this? People see this chart? Yeah. So would you agree that this statement is saying we got both 1s and we got both 2s and we got both 3s? That all values are work. So in our universe, we got lots of checks. All right, so now do you agree that A2 is true? Do you agree that B4 is true?
It works, and I understand what you're saying. It's that when we just the top.
Yeah. And what confuses me is this question doesn't seem to be using Oracle 1. And that does make me nervous because it tells me, I assume that wasn't the intention of the author. So either the author was wrong or I'm wrong. And I'm doing it on the fly. So it makes me nervous. Do you have any complaints about this proof? It's a whole different thing. Yeah. Yeah. I mean, let's give some thought to Oracle 1 and what did they have in mind with Oracle 1? Right? I mean, it's saying for all x, and then it has there's a solid bracket there, right? There's a solid bracket around that whole thing. So we want to bring the negation in, and we get that there exists a y that it's not true yx, and which is funny. They flipped it here, which is kind of funny. And that is an or. So again, we turn it to and negation of, right? So I would say that we can do the same thing as we did before. This is for all x this and for all x this, right? So we can say for all x, there exists the y such that not yx is one statement, and for all x, not t of x, right? So that gives us, as you're saying, that gives us this again, right? But this isn't all that useful, right? Because for every x, it's only giving us one y, right? Yeah? Oh, yeah. Yeah, very good. Not only is this not useful, but it's killing us, right? Because here, what we're wanting is for every x and for every y, right? So right, here's x, here's y, right? And this one says for every x, there's a y where it's not true. Maybe this one and this one and this one and this one, right? Well, this guy is saying the entire matrix is true, right? So they seem to be, the first oracle and the second oracle seem to be contradicting each other. Aren't we enthusiastic about the test on Wednesday? I mean, let me say, I think the one in the test isn't this hard. And it may be still too hard. Who knows? How are people doing with this? Yeah, it's a lot, isn't it? Yeah. No. Well, sometimes it means that the statement's not true, and sometimes it means that the statement is definitely true. In this case, what we're trying to prove, right, is the A and B gives me C, right? But we're saying that these contradict each other and become false, right? So then we're getting false implies C. And what does false imply C? It's true, right? Because we don't have the left hand, right? If you don't have the left hand side, right? Yes, that's for sure. That's for sure. You need the thing needs to be valid. So you definitely have the huge for all universes on the outside. Yeah. Good question, though. It was a close save, but right. We can do more of these, and but let me just say again, right? Somehow it's becoming clear again that we have to focus on the bracket, right, and the parsing of the tree, right? So give some thought to that, and then really just play the game, right? And the only hard part is if you need to give something in your oracle, what do you give? If you need to construct something, what do you construct? And I think in the test, that's going to be obvious, right? Just blindly do what you're supposed to do.